Hi, this is David,
And I'm Justin.
and this is our 6205 final project on pose detection.
aka Budget Just Dance. To start, let's begin with a quick demonstration of our pose detection method. The setup for our pose detection requires a green screen background and an HDMI-capable monitor. We tune out green color using YCRCB with thresholds set by 13 out of the 16 switches. Switches 0, 4, and 5 control what is shown on the screen. Let's switch to see our green screen in action. We found that applying a simple green screen will generate a lot of noise, especially at the edge of objects. For our skeletonization algorithm, we want to input one contiguous blob, otherwise stray artifacts may appear. So we apply a 4x bin downsampling algorithm to both reduce noise and improve computational efficiency in future stages. Here we switch from chroma green to a post-bin version.
The skeletonization algorithm I wrote iteratively removes pixels based on the surrounding 3x3 pixel grid. Based on the surrounding pixels, we can determine whether or not a pixel is on the border of our blob. If it is, we can remove it, resulting in a thinner blob than we started with. All of this is iterated many times, resulting in a one-dimensional skeleton in the end. Let's check out the skeletonization algorithm in action.
As we visually demonstrate the pose comparison algorithm, let's talk a little bit about how we compare two skeletons. To compare skeletons with each other, we compute a heat map scoring array of a benchmark skeleton. The heat map has equivalent dimensions to our downsampled space and maps every pixel to a number equal to its distance to the nearest point on the benchmark skeleton. This way, when we want to calculate how similar or different two skeletons are, we can sum over each individual pixel distance and assign a final score to the cumulative average. We rate the pose on a scale from 0 to 7, with 0 being the closest to the benchmark pose and 7 being the furthest.
The computation of this heat map is done by a two-pass method that only requires 2 iterations of the benchmark skeleton pixels. So scoring happens very quickly. In fact, it happens so quickly that we have to display one score for every 10 that we actually calculate to make it readable. Let's see this comparison in action.
And that's our project. Thank you so much for listening.
Wait, I feel like you were in the frame.
But yeah, just move around like a little bit. That's good, that's 0. Or back. Or you're like moving too much each time. No, the arms were good. Yeah, lower arm. Good.